Hello, and welcome back to another STEM department video, which is focused a bit more on the math and physics part of STEM. So, today I'm going to be presenting a new software called Maple. And this one is a math engine that will help you solve your different problems, your different math and physics problems with coding. I think that this software will help a lot, especially for online school and learning on your own. And plus, it is free for students until June 30th, 2020. So go download it right now so that you can follow my tutorial. And like I said, it's free, so it could help it helps so much, and I'm excited to put together a tutorial for all of you. This is what Maple looks like when you enter. Well, not entirely, because this is just my schoolwork. With this specific document, we will be sticking to kinematics, something simple, something easy to get you started with Maple. This is just a tutorial from a student's point of view. Little things I figured out or I learned step by step, just like experimenting with my courses. So the question reads, while entering a freeway, a car accelerates from rest at a rate of 2.4 meters per second squared for 12 seconds. How far does the car travel during those 12 seconds? And also, what is the car's final velocity? So, after reading this question, and by the way, I got this question off of Khan Academy because all of my work, if I can show you, is in French. Let's just get this done. So to start off, we're going to write our very first sentence to say what exactly we're going to try to find, since there are two parts to this question. So we have we're going to write printf, open your parentheses, add your two quotation marks already, because we're engineers, we're mathematicians, we want to go fast. And well, not too fast where you don't understand, but fast enough. And you would add your semicolon at the end, because in this you really need to add that in order for all your lines to work. So you add that at the end. Yeah. So we have our title. We could do this in A and B. Let's just do this in A and B. A is distance. Our next part will be the final velocity. To add space, because you can see that it's kind of, there's not enough space. We can add a slash and an N, and it gives you space at the bottom here. So it's way better. And now here, we're going to start off with our first equation. We're going to hop right into it. So you can write equation EQUA or just EQ. I just use EQ. Open up the brackets, put the number of the equation in it. Since this is the first equation, I put 0, 1. And then you're going to do two dots and an equal sign. And this is very, very important. For every time you're going to be writing your equations in Maple, you always need your two dots and your equal sign, or else you will have errors. So don't forget those. For this, we have our car accelerates from a rest rate. We have our acceleration, and we have our time. So we can do this in different ways, but I want to try out the third equation from the 5 one-dimensional movement equations. So we are going to do delta x is equal to your initial speed times your delta t plus, yes, it's plus, half of your acceleration times, once again, delta t, but this time squared. And to finish off the equation, to close it off, you would do two dots, EQ, 0, 1, and a semicolon, and that gives you your equation. So here I already have my delta t procedure in here, like this is the input over here. I don't have my delta x, so let me just add it up here. And it's the same for delta t, it's just a different, obviously, variable. Let's do that. And there it shows your delta x, so you would just make sure you press enter over here to roll your procedures, and then you press enter over here and it gives you your what you need. So that's your first equation. Now we can move on to the second one. So I'm naming it 0, 2 this time, 2 dots and an equal sign. And we already know that it starts from a rest rate. So we can just change it automatically. Since it would be 0 times the time, it would be useless to just have your initial speed. So we're just gonna do half times your acceleration times your delta t squared. And if you want to explain it, obviously you could just use printf. Okay, so for the third equation, I just went in and put the EQ03, and we have what we want. We have the equation that we need to find our distance. So we are just going to put in, we're going to substitute our values. So we're going to put a parentheses, your squiggly brackets, if that's what you want to call it. Just close in the squiggly brackets. Put your comma, because it's very important to announce which equation you are pulling. My bad, my mouse is always in the way. Which equation you're pulling your substitution from. So we want to substitute in from the second equation, since the first equation is this one, and we want this one. So this is why we put equation 2. We close the parentheses again, and then we're going to close up the 0, 3. This is just for names. You could also just put subs instead of like equation 03. You could just go straight to subs. But this is just to name it, to keep more of a organization in all of this. So the values we have here, we have our acceleration, which is 2.4. And then we also have our delta t, which is equal to 12 seconds. Make sure that everything's good, and we press enter, and this is our answer. We have 172.8. If we wanted, because there's so many zeros after it, we could just put eval f, open your parentheses, go over here at the end of your equation 2, open another parentheses, and in it, you're going to write, you just want 1, 2, 3, 4, so maybe 4 numbers, and it would simplify to your 172.8. So at the end, you would just put your printf again to write your final sentence, which would be the car travels 172.8 meters. So that is the answer for A. Now before I do part 2, which is question B, I want to give you guys the chance to work on it on your own and then join me for a second part. Thanks for watching.